So now we extend what you've just learnt to the point where you can sketch a rational function in the form one function divided by another function, where both of these are polynomials. Now, as your textbook notes, if the function on top is just a constant, then you can divide throughout on the bottom and you can already sketch it. For example, this one here, the constant on top is 2, but if you divide everything, all the terms on the bottom by 2, you just get a polynomial on the bottom and 1 on the top. So that you can sketch this already, and then you draw the reciprocal of that, which we just did. And of course, if the function on the bottom is just a constant, then you just divide every term up the top by that constant, and again, you've got a polynomial, you can already sketch that. So we're focusing here on functions like this, where f and g are non-constant polynomials. In particular, although the textbook says linear or quadratic, we actually have to go all the way to cubic, because your syllabus specifically says that you have to sketch the graphs of simple rational functions where numerator and denominator are polynomials to degree 3, without technology. So let's get on with it. Here there are actually 3 examples here. This is where you've got a linear function on top and bottom. It's very similar to what we just did, except the asymptotes aren't, like the horizontal asymptote is not the x-axis. It's away from the origin. This one has quadratic on top and bottom, and this one's actually got a slanted or an oblique or diagonal asymptote. That happens when they aren't the same degree. So that's the sort of things we're going to be looking at in the next few videos. At this point, you might be wondering whether there's a simple sequence of steps you can always follow to sketch such a function. Now, your textbook lists them like this. Simplify the function first if possible. Work out the coordinates of all the intercepts. Determine the various asymptotes that are vertical ones. Work out the equation of any other asymptote or asymptotes there might be. And finally, determine the coordinates of any other points, if you might need them, and then sketch. Now, I actually learnt basically the same steps, but when I learnt it, there was a little acronym. I'm going to see if I can show you that. I learnt it as ideas. I is for intercepts, D is for discontinuities, I can't type, so that's the vertical asymptotes where the function is not defined because it's discontinuous. E is extremities, what happens when x gets very big and when x gets very small. Asymptotes, that's horizontal or diagonal asymptotes based on the function. And then S was stationary points. So you can find the derivative, set it equal to 0 to find the various stationary points. If you prefer, you could think of this one as special points, because when you're doing a reciprocal function, for example, you can think about other special points like where the reciprocal crosses the original, like y equals 1, things like that. So this is the acronym I learnt when I was learning to sketch graphs. If that helps you, by all means do it in this order. It doesn't really matter the order. It's just a way to remember whether you've actually thought of everything you need to before you start sketching.